Hello ladies and gentlemen, welcome to Unit 5's last page. I'm going to be working on number 27. So the first thing I want to do with this problem is I want to graph it, but this can be a little confusing, especially with logs, where some people don't understand how to plug in values for x, and it actually makes more sense to plug in values for y. But what I'm going to do is I'm going to show you a trick to this. So what I'm going to do is I'm going to write log base 4 of x, which is in a sense the parent function to f of x. So what I'm going to do is I'm going to graph that in terms of y. I put down that I have a vertical asymptote, and I also have an order pair at x equals 1 and y equals 0. And then we get this graph that comes up and looks just like this. Okay, and that's basically our log base 4 of x. Now I can talk about any individual pairs, or maybe it's a little bit steeper, but that's really it, that what I'm concerned with for the non-calculator section for graphing. So what I'm going to do here is now I'm going to relate it back to f of x, and I'm going to do that in blue. So when it has this x minus 3, that means I'm moving 3 units to the right and 1 unit up. So the only order pair that I have is 1, 0. I'm going to move it 3 units to the right, 1, 2, 3, and then 1 unit up. Place that point right there. And I also know my vertical asymptote is at x equals 3, so I'm now going to move it over 3 units. So it's going to be x equals 3. Then I draw my line to connect that point and go on from there. Okay, so that's my graph. Now, not everything's going to be perfect, but I really just want to make sure that you're going in the right direction. You at least have one point that you're intercepting, and that you moved everything over according to the specific type of function. So let's go over the domain. The domain is going to be 3, which we don't actually include 3, to infinity. The range, on the other hand, is going to be negative infinity to infinity. The x-intercept. Now, this is when we set y is equal to 0. So when we set y is equal to 0, we're going to do some work. 0 is equal to log base 4 of x minus 3 plus 1. Bring the 1 over, so I get negative 1 is equal to log base 4 of x minus 3. Do the exponential form, so 4 to the negative 1. 4 to the negative 1 is equal to x minus 3. Now I need to write that as a fraction, so 4 to the negative 1 is just 1/4. Then add 3 to both sides. So this is where I get 3.25, or you could also say 3 1/4 is equal to x. So the x-intercept, 3.25, comma 0. The y-intercept, we can take a look at our graph. Does it ever hit the y-axis? Well, no, so we're not going to have one. And the asymptotes, that's going to be x is equal to 3. Number 28, I'm going to move some things over. So to do some of these calculations, what I do here is I could still, yet again, I could make a table in x and y and plug in values and other things like that. Or I could relate to its parent graph, which is going to be 2 to the x. So 2 to the x has an order pair at 0, 1, and has a graph that comes up just like this. And a vertical asymptote at a horizontal asymptote at y is equal to 0. Now, if I talk about its movement, how it's going, so I move plus 1, so that means I'm moving to the left 1 unit and down 3. So take the order pair that I originally had, move it left 1, down 3. 1, 2, 3. Place my point right there. Horizontal asymptote now changes down 3 units. And my graph is going to look like this. Okay, now let's figure out the domain and range. Domain, going to be negative infinity to positive infinity. The range, on the other hand, since the lowest value goes down to negative 3 but goes all the way up to infinity, we're going to say negative 3 to infinity. The x-intercept. Now, it does have an x-intercept and a y-intercept. So for the x-intercept, we're going to place in y is going to be equal to 0. So let's do some of the calculations. 0 is equal to 2 to the x plus 1 minus 3. Bring the 3 over, so I get 3 is equal to 2 to the x plus 1. Now, to get the x plus 1 down, get away from the 2, we do log base 2 to both sides, log base 2. So log base 2 of 3 is going to be equal to x plus 1. And then subtract 1 on both sides, so we get log base 2 of 3 minus 1 is equal to x. Now, as weird as this is, that is going to be our x-intercept. So log base 2 of 3 minus 1, comma 0. Because we can't actually figure out the decimal version, that is going to be our acceptable answer. Now, y-intercept, that's when we set x is equal to 0. So we do 2 to the 0 plus 1, minus 3, and you can almost do this in your head. 2 to the first, which is 2, minus 3, which is going to give you negative 1. So our order pair is going to be 0, negative 1. And the asymptotes, that's going to be y equals negative 3. Now let's work with 29 and 30. So for these two, you're going to be expanding. Now, there's a couple ways of rewriting these, but the way that I would like to see on the test for you to get a full credit, I would like you to start off by saying log base 3 of x squared plus log base 3 of y minus log base 3 of z to the third. So the minus there, which means that the z is going to be on the bottom, and the x squared and the y, since they had multiplication, we want the operation to be addition in between. Now, before we finish up, I want to make sure that this 2 and this 3 right there come down in front of the log. So we should get 2 log base 3 of x plus log base 3 of y minus 3 log base of 3z. And that's my answer expanded. Now 30 on the other hand, I'm going to actually go into the condensed spot for 31, but we'll go over 31 in a little bit. So I'm going to rewrite this as log base 4 of 16 plus log base 4 of square root of xy. Now, I can rewrite this square root some other way. I can actually rewrite it as 1/2 to the 1/2. So log base 4 of 2, or excuse me, log base 4 of 16 is going to give me 2. And then if I bring the 1/2 down, and then I split up the x and y, I need to make sure that that's on the parentheses on the outside. So log base 4 of x plus log base 4 of y. And that's going to be my expanded version. Now, if you wanted to distribute that into those, that would be fine as well. Or you could keep the 1/2 on the outside. Does not matter. I would still give both credit. 31. Now to start this off, I'm going to, instead of write minus 2, I'm going to write that as plus negative 2, and then make it as the exponent of y. So I can see that every single part here has addition, so it's going to be x minus 1. Then I write the multiplication with y to the negative 2, and then another multiplication with x. And it's all underneath ln. Now to rewrite this properly without the negative 2 for the exponent, we make sure that the y is now going to go to the bottom in the denominator spot. So I'm going to just rewrite this as x times x minus 1 over y to the second, and that's all underneath ln, which is going to be my condensed version. Now there's other ways about thinking about this, but really you should have x times x minus 1 up top, and y to the second should be in the denominator. And to finish up the last two, the change of base formula, what we start off with is we just start off with just a normal log of the actual size number. So 10 is the larger size, so that's going to be 10 over log of 8. Not the actual numerical value, but the size itself. So since 10 is the larger number, that starts, and then log of 8 goes on the bottom. So that gives us an estimation of 1.107. And I round to nearest 3 decimal places. And then same thing for the other one, log of 5 over log of 13, which is going to give us 0.627. Well, I hope you enjoyed these videos. Please click the link in the top left-hand corner to go on to any previous videos, or click the link in the description down below. Thank you for watching, and have a good day.